Hey everyone, so I'm going to do the review sheet for your test this Friday. Alright, so the first question is saying, let R be the shaded region bounded by the curves y equals e to the x sine 2x and y equals x squared. Find the area of R and have all these following parts. So the first thing I'm going to do is I'm going to draw a picture of the region. So here's my y and x axis. The picture that I'm concerned about, it's a really funky picture, but this is the section that I'm concerned about right here, because that's where the curves intersect. So this region. So this whole question is basically going to be based upon this shaded region here. So for part A says find the area of R. One thing I'm going to do is I'm going to label the curves. This is e to the x sine of 2x, and this is x squared. Okay, so basically what I want to do is I want to find the area first. To find the area, it's just the integral from whatever this bound is to the other bound, and you subtract the upper curve minus the lower curve. So the intersection that's here is 0, so my lower bound is 0, and this x value here is about 1.328. And I just get that by using my calculator and finding the intersection value. So 1.328 is my upper. Then I need to find the upper and the lower curve so I can subtract them. My upper curve is the x squared, so I know that I have x squared. Actually, it's not. My upper curve is the sine curve because that's the blue curve. This blue curve is the upper curve. So it's going to be e to the x sine of 2x minus the lower curve, which is the black curve, x squared dx. I'm going to put this whole piece into y1, and then I'm going to put second calc 7 and calculate the area. And that'll give me a value of 1.306. Okay, the next part says find the volume of the solid generated when R is revolved around the line x equals 3. So I'm going to redraw the picture for myself so that I can see it. So I'm revolving this region around the line x equals 3. X equals 3 is over here. So I'm revolving around a vertical line. So when I do vertical, I want to use the shell method. And I'm going to go from 0 to 1.328. So again, with the shell method, you're using the x bounds as you would use the x bounds for the volume. It's the same way. So I need to figure out my radius, and I need to figure out my height to use the shell method. So my radius is my distance from the axis of rotation. Usually what I do is I draw myself a little rectangle in here to find that distance. It's from here to there. So it's going to be 3 minus x. Also, it's on the right side of the y-axis, so you're subtracting. And my height is going to be the upper curve minus the lower curve. The upper curve is the e to the x sine 2x, and the lower curve is the x squared. That's this lower curve and then the upper curve. So inside my integral, I will have e to the x sine of 2x minus x squared dx. And I'll put this whole piece into y1 and then multiply it by 2 pi. And then do the second calc 7, 0 to 1.328. When I do that, I get 2.939, and then when I multiply it by 2 pi, I end up getting my answer of 18.467. The next part, part C, wants you to revolve the region around the line y equals -2. So it's the same region, this one and this one, and they want you to revolve it around y equals -2. So that means that my revolution is happening horizontally around y equals -2. A horizontal revolution, you're going to use the washer method. It's going to be the same bound, 0 to 1.328. And what you need for the washer method is you need the upper curve squared minus the lower curve squared. But the deal here is that we have a distance from the line y equals -2. This is capital R of x. That is going to be 2 plus e to the x sine of 2x, and then I'm going to square that. Okay, and then minus 2 plus the lower curve, that's little r, that's going to be 2 plus x squared dx. Then I'm going to put this into my y1, and then in the end I'm going to multiply that value by pi. So when I put that into y1, I'm going to do second calc 7, and I'm going to do from 0 to 1.328 and multiply this by the value that comes out of the integral, and that gets you 26.808, and that's after you multiply by pi. So give me a second. It's really pi times whatever comes out of the integral, and that would be pi times 8.533, and then your answer would be the 26.808 that I got. Okay, so the next part, part D, I'm going to draw a picture again. The part D wants you to revolve it around the x-axis. So I'm going to draw my picture again. Here's the e to the x sine 2x, and this is the x squared. And I'm revolving around the x-axis. Okay. So when I revolve around the x-axis, I'm going to still use the washer method because there are two curves, and I'm still going to have the 0 to 1.328, and all I need is the upper curve minus the lower curve. The upper curve is going to be from the x-axis, that is still e to the x sine of 2x squared minus the lower curve, which is to here, and that's x squared dx. I'm going to plug this into y1, and then I am going to multiply that output by pi. So second calc 7 from 0 to 1.38 when this is put into y1, and it's going to be pi times 3.307, and when you do that you get 10.391. Part E wants you to revolve the region around the y-axis, so I'm rotating around here. That's my region again, so e to the x sine 2x and x squared. This is the region that I'm revolving. It is a vertical rotation, so I'm going to be using the shell method from 0 to 1.28, 328. And I'm going to draw my rectangle in here again so I can visualize what the radius is. My rotation is around the x-axis, so this is the r value from the axis rotation to the curve. So that's just x because it's just the rotation around the y-axis. And then my height is going to be the upper minus the lower curve. So it's going to be e to the x sine of 2x minus x squared dx. I'm going to put this into y1, and then I'm going to multiply the output by 2 pi. So I'm going to end up getting 2 pi times 0.980, and then you end up getting 6.16 for your answer. Part F asks you to rotate around the line y equals 4, so that's up here. My region looks like this again. Alright, because it's a horizontal rotation, I am going to use the washer method. So v equals pi from 0 to 1.328. And I need the distance from my axis rotation to the farther away curve. This is going to be 4 minus x squared minus to here, which is 4 minus e to the x sine of 2x squared dx. Okay, so I'm going to put this into my calculator, this into y1, and I'm going to multiply that by pi, whatever comes out, and that's 7.144, and that ends up me getting an answer of 22.444. The next question says the shaded regions R1 and R2 is shown above enclosed by the graph of x squared and 2x. So it says, part A says find the x and y coordinates of the 3 points of intersection. So it doesn't ask you to find it algebraically, but you do want to show that you know that to find a point of intersection, you're just setting equal the two functions. So f of x equals g of x. F of x is x squared. That's equal to 2x. So I'm going to put x squared into y1 and 2x into y2. And then what I'm going to do is I'm going to find the intersection by using second calc intersect. I did need to change my window to be a little bit bigger in order to see the intersection that was over here, just as an FYI. So what I did was I did that command on the calculator, and I ended up getting my first intersection of negative 0.767, comma 0.588. My second intersection was 2, comma 4. And my third intersection was 4, comma 16. So on the diagram, because I want to probably see it, this value here for that intersection was 4. Then this one here was 2. And then this one here was that weird negative 0.767 value. Now for part B, it says, without using absolute value, set up an expression involving one or more integrals to find the total area enclosed by the graphs of f and g. That means you want region 1 plus region 2 to get the area, because they want both the area enclosed by those two graphs. So to find the area, I'm going to do the integral from, I need to actually do 2, because there's a region here and there's a region here. Okay, so I'm going to do negative 0.767 to 2. And I need an upper minus lower, so I need to know which curve is which. This curve here, if I follow it, this curve is the parabola. That one is x squared, and this one here is 2 to the x. Okay, so I know that for the blue region over here, right here, my upper curve is the 2 to the x, and my lower curve is the x squared. So it would be 2 to the x minus x squared dx, that's the first region, plus 2 to 4 for the second region, and that's going to be 2 to 4, and the lower curve is 2 to the x, and the upper curve is x squared, so it's x squared minus 2x. To the x dx. All they want you to do is set up the integral, and you don't have to solve it, so that's your answer for part B. Now for part C says without using an absolute value, set up an expression involving one or more integrals to find the volume of the solid generated by revolving R1 about the line y equals 5. So R1 is this region here. I'm going to do it in green so you see it. R1 is this region here. Okay, I want to revolve that region around y equals 5, so the line's going to be up here. It is a horizontal rotation, so that means I'm going to be applying the washer method onto this. So v equals pi. The lower bound is negative 0.767, and the upper bound is 2. And I need my capital R, which is going to be towards the farther away curve, which is x squared. So x squared squared. And my closer curve, which is 2 to the x squared, minus 2 to the x squared dx. Now, I already noticed what I did wrong here, because I'm going from y equals 5, and I didn't even take that into play. So I should probably change all this up, because I know that I'm going to have an incorrect integral. So this is incorrect. So I'm sorry for making this slight mistake, but at least you can see that you need to realize that that y equals 5 comes into play. So it's pi negative 0.767 second. And because it's from the line y equals 5, my axis of rotation is going to change how the washer method is demonstrated. So instead of doing just the x squared like I had here, I need to do 5 minus x squared squared, because the axis of rotation has changed and it's not just the x-axis. minus 5 minus 2 to the x squared dx. Now, if you notice, they asked you to not evaluate it, so that is your final answer. The next question says solve part A and B algebraically using integration techniques and solve for each part. So the first thing says that they want you to find the area. So part A is finding the area. The first thing you want to do is find these intersection values. Those are -2 and 2. So to find the area, I'm going to calculate the integral from -2 to 2. And I'm going to need to do the upper minus the lower. So the upper curve is 4 minus x squared dx. To do this out by hand, I'm going to do 4x minus x cubed over 3 from -2 to 2. And when you end up solving that out by hand by doing upper minus lower, so it would be upper minus lower you end up getting an answer of 32 over 3. So that's your area. Now the part B asks you to find the volume, revolving it around the x-axis. The x-axis, let me just draw a picture over here. So here's y equals 4. This is -2 to 2. We're revolving it around the x-axis. If it's a horizontal rotation like this, you are using the washer method. So pi from -2 to 2. And the farther away curve is y equals 4. So that's 4 squared minus. And the closer curve is the x squared. So it's minus x squared squared dx. Now notice, unlike the previous problem, I do not need to add or subtract to the r and little r. So that's because the axis of rotation is the x-axis. Alright, so to do this out algebraically, I'm going to clean this up a little bit. This is pi from -2 to 2, 16 minus x to the 4th dx. Okay, so I'm going to integrate this. So it's 16 times 16x minus x to the 5th over 5. We're going to evaluate this from -2 to 2. I'm going to show my upper minus lower. So it's pi times whatever happens here. So upper is 16 times 2 minus 2 to the 5th over 5 minus 16 times -2 minus -2 to the 5th over 5. And I'm going to put this into my calculator here. So it's going to be pi times 51.2. And that's really pi times 256 over 5, I'm sorry. So that's your answer really. Or you can write it as 160.85 if you rather that. Question 4 says let R be the region enclosed by the graphs of square root of x minus 1 and the vertical line of x equals 10. So the first graph I'm going to draw is the square root graph, and it looks like this, and that's at 1. And then x equals 10 looks like this. So the region we're concerning ourselves with is this region here. It says find the area. So to find the area, I'm just going to find the integral from 1 to 10 of the square root of x minus 1 dx. I'm going to put that in my calculator in y1, and I end up getting an area of 18.00 something, but I'm just going to round to 18. For part B, it says find the volume of the solid when it's revolved around the horizontal line y equals 3. So I'm going around y equals 3. This is going to be a disk method just because, actually no, it is a washer method because it is creating space here. If you notice that, there's space here. So when it gets rotated around here, you're creating a hole. So when I do this, I do need an upper and a lower curve. So I'm going to do pi from 1 to 10 because those are my bounds. My farther away curve is actually the x-axis, because they do tell you in the beginning of the problem that it's bounded by the x-axis. So my farther away curve is the x-axis. So I have 3 minus 0 squared, because that's what the x-axis is. It's really y equals 0. And then I have the closer curve, which is minus 3 minus the square root of x minus 1 squared dx. So I'm going to put this into y1, and then I'm going to evaluate the integral from 1 to 10 by using second calc 7, and I end up getting 67.5. You could leave it like this, or you can make it into 212.058 if you multiply it by pi. The last part asks you to rotate it around the line, vertical line x equals 10. So my picture looks like this. Here's the 10 that the region is enclosed by. So this is your region from 1 to 10. Now notice they want you to revolve around this, which is kind of interesting because it's on the bounds, but that doesn't really change anything. It's still going to be a shell method because it's a vertical rotation. So when I do that, I want to make sure I have 2 pi on the outside from 1 to 10. I'm going to draw a rectangle in here just so I can visualize it. I'm going around that line, so my axis rotation is from here to here. That's my radius. So it's going to be just like any other. It would be 10 minus x, and then my height is the distance from here to here. And because there's not a second curve, it's simply just x minus 1. You could do x minus 1 minus 0. That wouldn't change anything, but that's really it. Put this into y1. I'm going to do second calc 7 and multiply my outcome by 2 pi. So it's 64.8, which is going to get you an answer of 407.151. All right, I hope this video helped. I'll see you guys soon. Study up.